Hey there, and welcome to our webinar today, Making Enterprise Content AI Ready. We're going to spend the next 40 minutes or so giving you everything you need to know about how Retrieval-Augmented Generation, or RAG for short, how it works, why you need it, and how you can best connect it to your corporate content to fuel generative AI. And to guide us through this conversation today, we've got a fantastic set of speakers. My name's Dave Jones. You've already met me briefly, and I've got the pleasure of working with Docuvela as a strategic marketer. My background includes time with the likes of Highland, Nuxio, and Konica Minolta, and I'm also a member of the AIM Company of Fellows. If you haven't come to listen to me today, the two people that you've really come to listen to are the co-founders of Docuvela, Ellen Ryan and George Steimer. Now, Ellen has 28 years worth of experience in content management. Her career at technology services group Alfresco and Highland Software has focused on serving customers, providing expert guidance, and building long-lasting relationships. She's well known for her ability to simplify complex technology challenges, delivering high-value solutions and results. And she co-founded Docuvela with George in May 2023. Now, George has 24 years worth of experience in design, development, and implementation of content services solutions and products while at Technology Services Group, Alfresco, and Highland. He's also got an extensive track record of building innovative content services products, having led product and engineering teams to build the Alfresco Content Accelerator and the Alfresco Enterprise Viewer. Welcome both.
Great to be here. Thank you.
Thank you. Thank you. So I want to take a moment to set the stage for what we will be talking about today. Legacy ECM platforms are at least 20 years old. Some are 40 years old, and all were designed well before AI and well before the cloud. These legacy software platforms were developed in an era of enterprise software that aimed to be one single source of truth, right? And they wanted to manage the content across the entire organization. So it's not surprising that we see these large, monolithic, locked architectures that is storing content behind proprietary databases and proprietary APIs. Even legacy systems that run in the cloud remain server-based, making them complex and expensive to maintain. The bottom line is that these systems prevent your organizations from making their content AI ready. So we can't only think about the architecture, but we need to think about the content. Is my content AI ready? We have spoken with lots of IT directors that are being asked from the C-suite if their content's AI ready, and the resounding answer we're getting is no, it's not. And there are two major concerns: is changing content and security. So what happens when my content changes? Can the AI system forget what it had remembered and replace it with something new? And how do I keep certain content from being seen by people who should not have access to it? So AI ready content services is what we aim to provide with the Veladocs platform. So for any listeners who have not watched our Veladocs launch webinar, be sure to check it out to learn more about the platform. But in a nutshell, content is AI ready when it resides in a cloud native serverless architecture that supports scalability, both up and down. And most importantly, the architecture must also provide transparent or open access to content and data. The way we would propose to do that is through native cloud APIs and access points. Large language models, or LLMs, and other AI technologies will be able to access content and data natively if it sits in a place like S3 or OpenSearch, but it is doubtful that they will support integrations with legacy ECM systems requiring content to be accessed through proprietary APIs. So openness and transparency is really paramount. And it goes without saying that all of this needs to be deployable in a cost-effective manner. Implementing AI solutions with RAG, or Retrieval-Augmented Generation strategy, allows for a significantly lower investment. So now I will hand things over to George, who is going to dive into more details on what RAG is and discuss some different approaches to RAG. Thank you, George.
Thank you, Ellen. So yeah, let's talk a little bit about what exactly is retrieval augmented generation in RAG. So just to kind of set the stage before we jump into what RAG is, let's talk a little bit about how an LLM works natively. So, I'm sure most of our listeners have used an LLM like ChatGPT from OpenAI or any of the others. These LLMs are typically built by very large organizations that have a lot of resources, Microsoft, Amazon, OpenAI, and the rest here. And they train these models on billions of pieces of data. And they're very expensive to build and create. You can fine tune them, but that doesn't really give it a domain specific knowledge. It's more like small tweaks and tuning to how the LLM will respond. But in general, when you make a request to one of these LLMs, like whether it's through a web browser or through their APIs, you're sending a request, a question, whatever you're asking the LLM, and it generates a response. And that response is based on its training data. So there are some limitations with the LLM to be aware of. The first is the knowledge cutoff, right? So I'm sure we've experienced this if you use ChatGPT, that if you ask it a question, it may respond with something like, my knowledge is only through September 2022 or something like that. But it's sort of like a professor that just decides to stop learning one day. And there is that knowledge cutoff where it can't answer questions like what happened in the Cubs game last night or how has Tesla stock trended over the last 30 days, because it's cut off from where its training data ended. The other is that it has very, very broad knowledge, which is great, but it doesn't have domain specific knowledge. So it can answer questions very, very well, like what should I plan as an itinerary for my next vacation to whatever destination? But if you ask it about part 1, 2, 3, 4 in your supply chain, it's not going to know anything about that. As we talked about in the last slide, these LLMs are very expensive to train and create, hence why it's a lot of the biggest organizations that are doing this. Ellen earlier talked about, doing allowing enterprise AI to be cost effective. A not cost effective way to provide domain specific knowledge to an LLM would be for an organization to build one of these from scratch. That would be very expensive. And we've also all heard of, hallucinations that can occur. So there is sort of a risk of a lack of trust from the users. So if the LLM makes mistakes, especially when, enterprise processes are involved, that can cause sort of a feedback of a lack of trust with the users with what the LLM is saying. And as we all know, the LLM will respond in a very authoritative way, even though what it's saying might not be correct. So retrieval augmented generation is a strategy that aims to improve the quality of the LLM responses. And the keys are really, this is a quote from IBM here, but the keys are really focused here in blue, is that the aim of RAG is to improve the quality of the LLM by grounding the model on one or more external sources of knowledge. So let's talk about how that actually works. So if we go back to really what we talked about earlier of asking a question to the LLM and it generating a response, here's where RAG fits in. And before we do anything, we need some sort of trust layer. Typically, this is contractual. So if we're going to send enterprise information to an LLM, we need to trust that an OpenAI or Microsoft or Amazon or whoever isn't using that data for purposes that aren't authorized. So that's sort of the first thing to think about when it comes to an enterprise AI system using one of these tools. But where RAG comes in is instead of just sending that question directly to the LLM, we intercept it with some sort of system that we're going to call a smart retriever here. That smart retriever then looks up information in a knowledge base, which then returns the relevant information. And we augment the user's question with that relevant information in order to provide a source-informed answer. So using the examples that I talked about earlier, if our knowledge base is box scores for, every day's baseball games, now when I ask the question, what happened in the Cubs game last night, it can go out, look up that information, return the box score, and the LLM can respond in the inappropriate manner. And in fact, if you go out to ChatGPT today and ask that very question, you will see it doing RAG. You will see it saying something like looking up information from the internet, and that's what it's doing. It's going out, getting the information, augmenting your question, and responding with the correct answer. So let's talk about the benefits of RAG. And some of these I think you may be able to guess as I've been going through. But the first is that it provides up-to-date information beyond that knowledge cutoff. That's, it's kind of like giving the LLM an open book exam rather than only basing its answers on the training data. The other is that you can provide it domain-specific information, whether that's, again, your the latest box scores or information from part 1, 2, 3, 4 in your supply chain database. This gives you greater ability to provide enhanced trust, so reducing hallucinations when it comes to, especially when it comes to domain-specific information that the LLM doesn't have. The goal of RAG is to reduce those or eliminate those hallucinations so that it's responding in a correct manner and users can trust the responses because it's based on the domain specific information source. And it's very cost effective when I was talking earlier that you could build an LLM from scratch, but that's extremely expensive. RAG is a much more cost effective tool to create or give these LLMs domain specific information for your business. So now let's take a look at how this works before we dive into the strategies for RAG. But let's take a look at how does RAG actually work. And I'm going to flip over to a demo screen and we will do just that. We'll take a look at how RAG works. Okay, so here we have just a really simple chat system. This is hooked up to the OpenAI API for ChatGPT. And what I'm going to do is I'm going to start it in a mode without RAG first. And in this example, we can see here RAG enabled is false. In this example, I'm going to pretend I'm a new employee at Docuvela, and I have some questions about how to set up my passwords. So here I'm just going to type a question. I'm going to say, and I'm going to ask it about setting up my passwords. And here it's responded, and you'll notice that first, it doesn't have any information about Docuvela's password policy, but it's responding in a way that makes sense. It's trying to be helpful. It's trying to provide just sort of generic information about setting up passwords in a good way. And there's a couple of ways to look at this. One, it's trying to be helpful. It's providing good examples, but it's really not specific to Docuvela or our policies. So let's try this. Let's try to ask a question that's even a little bit more detailed. So So I'm asking who approved Docuvela's password and security policies. And again, it's trying to be helpful. It's responding in a generic but authoritative way. And it's saying that it's typically developed and improved by the IT department. Again, it's helpful information, but it's not exactly specific to Docuvela. Or how about this? How about what? So if I want to know more, what's the document number for the password policy? And here we can see it has no idea. And it comes out and says that as an AI model, he doesn't have access to specific policies, and responds again helpfully, but without, very, very much detail. And I'm going to ask one more question here. Other documents. And here's just another example of it, trying to be helpful, but it's returning documents that really may or may not exist at Docuvela because it really doesn't know. So now let's ask these same questions, but I'm gonna, on my other screen here, I'm gonna flip this to RAG mode. And we're just gonna rerun this. And we'll here see that RAG enabled is true. So now I'm gonna ask these same questions. And in the interest of time, I'm just gonna copy and paste them. So now it's responded in a much more helpful way. I won't pull up the documents here, but these steps here for password management and requirements are taken directly from Docuvela's password management policy. So it's again, it's while you could argue that the previous example wasn't necessarily a hallucination, it was a generic answer, whereas this is much more specific. So now let's take a look at our other questions. So who approved the password and security policies? And this is responded exactly with who approved, their role, and you know, it's a much more detailed answer. Let's do this one here. Whoops. As you would expect here, it can respond very confidently and correctly that the document number is policy 101. And finally, let's ask it any additional documents. And here it's responded with other policies that the user should look at. And while this is just a simple text-based chat, you know, in a more complete system, we could provide these as links to actually allow the user to click the document and view it directly. Well, that's just a quick look at, you know, using a very, very simple chat system that's connected to the OpenAI API. And just an example of the differences of responses when the LLM has no context to our Docuvela policies, and you know, how those responses change when we use RAG to give the LLM that needed context. And now let's take a look at how you actually can do RAG. There's a few approaches for RAG. One thing to keep in mind is that RAG is not a product, it's a strategy. So how do we actually you know, accomplish a RAG system within enterprise? And we're going to take, you know, we're going to focus on enterprise content when it comes to these systems. And the first, if you go out and you start researching RAG, you're going to run into vector databases. Vector databases are sometimes equated with RAG, which we're going to talk about other approaches. But essentially here, what you're doing is you're taking documents or other information, and then you're chunking that content and embedding those chunks into a vector database, which allows for similarity searches to enable the LLM to utilize the information. We'll talk a little bit about how that works in a minute. The other approach, which we would argue works much better in an enterprise content perspective, is more of a real-time access to the documents. So rather than chunking up the documents and storing them in a database, just access the content directly from that content repository. So looking at the vector database approach in a little bit more detail, one of the tools out there that can enable the vector approach is a tool called LangChain. And this is taken from an Amazon source of, you know, just describing what LangChain is. But essentially, you take some documents wherever they're stored and chunk and embed the information from the document and put it in a vector database, which is used over here in the LLM loop to augment the user's question and provide an answer that's based on this information that's in this vector database. Critically here, one thing you'll notice is that this is sort of a closed loop. You know, it's whatever's stored in the database is the LLM's source of truth, and the system where these documents are stored is really outside of this loop. So what are some of the pros when it comes to using the vector approach for RAG? The first, obviously, is that you can put information in there, whether that is, you know, domain-specific information that was created whenever prior to the knowledge cutoff, or information that is new but is historical, it's not going to change, and it's providing the LLM with that information for use in its answers. The other is, given that it's a database, it is scalable just like any other database. You can scale it to large sizes and provide efficient retrieval and data input at scale. So let's take a look at, what are some of the challenges with vector RAG, and especially from the perspective of enterprise content. So as Ellen mentioned earlier, and this is kind of going to harken back to some of her challenges that IT managers have faced when it comes to making content AI ready, is how do you handle changing content? If you think back to the slide on LangChain, when documents change in that source, you have to somehow not only get the new information into that vector database, but you also need to remove any incorrect information. And that can be, it's possible, but that can be very difficult, especially since those documents were chunked into smaller pieces and embedded in that vector database. The other is security. Again, the exact issues that the IT managers have been concerned with is, again, since that vector database is part of that closed loop with the LLM, you need to somehow manage the security of those documents. If all of the information is public for the user base, then you don't have to worry about security. But in a lot of the organizations we talk to, there are strict requirements around who can see certain documents, and you need to be absolutely sure that users are not getting information from an LLM that does not pertain to their security level. The other thing to think about is just traceability when it comes to both auditing as well as source attribution. So since the vector database doesn't necessarily have context to the entire document, it has embedded chunks of documents. It's very difficult to do things like audit which documents were used in source, as well as concerns around source attribution and giving users links directly back to a certain document. While it's certainly possible, it's difficult, again, because of that. The source of truth of where the documents live is outside that loop of the LLM and vector database. And also just relevant content in general. With a vector database, you're essentially doing similarity searches. So while that works very well in some use cases, in other use cases, it might be much better to do a more traditional content search rather than just looking up similar documents. So an example of, find me contracts from vendor Acme in the last 30 days or in the last year over $1 million, that could be very difficult for a similarity search, but is trivial for a content search. So let's take a look at the real-time approach and how we aim to solve some of those challenges with the vector database with the real-time approach in Veladocs. So, just to start out, obviously, we still have that trust layer. If we're going to start sending enterprise content to these companies, we need to make sure that we trust, what they're going to do with that information. So we have our same request that goes to a smart retriever or RAG engine. And as we talked about, this is a strategy. So there's lots of ways to do this. But in the real-time approach, this RAG engine doesn't reach out to a vector database. It reaches directly to where those documents live. So here we've shown that they can be stored in Veladocs. And crucially here, could be indexed to sub-indices within OpenSearch. And so one of the cool things that we can do in Veladocs with OpenSearch is we can provide different security on these indexes and even documents within the indexes so that this user, when they make this request, they're only return documents that they have approval to see. So maybe index A has HR information and index B has financial information and C is manufacturing information. Certain users may only be able to see indexes B and C, but not A, or maybe another user could only see index A. This security is honored here because we're accessing the document where it lives with the security, rather than, again, that closed loop with the vector database. The other thing here that we can do that's unique from the vector approach is we can return chunks of documents, but we could also return the entire document if it makes sense. And we can also return metadata associated with the document. So a lot of times, especially in enterprise content, the content of the document is obviously important, but the metadata can describe a lot about the content that's also important, and may or may not be actually in the document. So both the content as well as the metadata can be used to augment the request, providing the context for the LLM to return an informed answer. One other thing to point out here is that while Veladocs certainly could be the primary source for these documents, or primary source of truth for the documents, if your organization uses another system, we could synchronize content to Veladocs, really to take out information from that enterprise system and expose it to AI in a more cost-effective and easier manner to retrieve the information and use it within this RAG engine. So some of the pros for the real-time RAG scenario is retrieving relevant content. As I mentioned earlier, when it comes to content, similarity isn't necessarily the best way to retrieve content. Sometimes you need to do a more content services style search on metadata. And also, I should also mention the relevant content could be based on versions. So as those documents change, the correct version is returned appropriately. Obviously, we talked a little bit about security on the last slide, but since we're accessing the content in its content repository with security, we can be sure that the users are actually only seeing content that they should see. We can provide domain-specific knowledge. This is something that obviously, based on the content that's exposed within the repository, provides that knowledge. But you could have multiple different repositories, and even you could combine approaches. So whether you're accessing different instances of Veladocs or other systems, or even vector databases when it makes sense, we can provide a comprehensive sort of view to the content in the approach that makes the most sense. And lastly, traceability. So since we are not chunking those documents and we're accessing them from their content repository, we can provide traceability both in the aspect of audit trails. So knowing that a user's response was informed by certain documents, we can audit that. But we can also provide links back to the full document for source attribution, or as we talked about in the demo, you can provide links to other documents for further reading, and give the user an easy way to access those documents. There are some challenges with the RAG approach that we'll talk through. The first is what's called the context window for the LLM. So LLMs typically both work with and are metered by what's called a token. So you can think of a token as either a word or a part of a word. And all LLMs have a limit to the amount of tokens that they can, quote unquote, remember. If you overflow this context window of tokens, it will just simply forget the, in a sort of manner where it'll forget the oldest and, just continue remembering what's in the newest tokens. Most LLMs have a context window of between 8 and 64,000 tokens. However, there are some recent LLMs that reach context windows of 1 million tokens, with rumors of a 2 million context window out there as well. But you also have to remember the implementation efficiency. So, throwing thousands and thousands of tokens at the LLM might be good in some use cases, but may not in others. So it's important with using a real-time approach to, efficiently implement that RAG engine so that you're sending it what it actually needs and not too much, but not enough. And also from a cost perspective, right? So since LLMs are metered by number of tokens, you don't necessarily want to, just send everything you can to the LLM. And really that comes down to what are you connecting to? When you connect to that repository in a real-time manner, it should be very easy to find, the appropriate documents so that you are, sending over the most, efficient number of tokens possible. And with that, I will hand it back to Ellen to talk about RAG and review.
So thank you, George. In summary, George just discussed two different approaches to RAG, the vector database approach and a real-time approach. Some use cases may squarely fall into the vector database approach and chunking of content and focused on that strategy. But AI use cases that rely on content that changes or has different security measures applied to it, or maybe needs to be retrieved in a more exact way, a real-time strategy is really required for that. And it's this real-time approach that we aim to provide with Veladocs. Thank you for your time today.
And with that, we're at the end of our session today. George, Ellen, thank you very much. And thank you all very much for joining us. We hope you've enjoyed the session today and found it useful. If you'd like more information on Veladocs, of course, you can visit our website at Veladocs.AI, or you can get in touch with us directly using the email addresses on the screen at the moment. Thank you again for joining us. And until next time, goodbye for now.